Hi, my name is Justin Irvine Original, and I will be presenting chapter 4.1, which is Indefinite Integral.
Hi everyone, my name is Vishalini Muniswaran. I'm going to explain about definite integral.
My name is Muhammad Ismail bin Abdul Aziz, and I will explain about the fundamental theorem of calculus.
Hi, my name is Farah Najwa binti Madrai, and I'm going to explain about integration by substitution.
Hi, my name is Amin Amir bin Amza. In this video, I will present the topic about integration by part.
Hi, my name is Vanessa Daniel Pichino Sabri and will present to you about integrating by partial fraction.
Hi, my name is Stephanie Fifiana Luis. I will present the topic about trigonometric substitution.
Hi, my name is Justin Irvine, and today I'm gonna present about indefinite integral. In this video, I will present or discuss about indefinite integral definitions, its applications, and a few examples. Indefinite integral can be defined as a function that takes the antiderive of another function. An antiderive or indefinite integral of function f if differentiable function f derive is equals to the function f, or this can be symbol state as f primes equals to the original function of f. The process of solving for antiderivative or indefinite integral is known as antidifferentiation, while its opposite operation is called as differentiation. Antiderivative or indefinite integral and definite integral both related through the fundamental theorem of calculus, which the definite integral of a function over an interval is equal to the difference between values of an antiderive evaluated at the endpoint of the interval. There are three most common applications of an indefinite integral, which is displacement and velocity, acceleration and velocity, and lastly, voltage across capacitor. In displacement and velocity, we can find an expression for velocity by differentiating the expression for displacement, which is equivalent of first derivative of displacement. In acceleration and velocity, we can find the expression for the acceleration by differentiating the expression for velocity, and this is equivalent to finding the second derivative of displacement. In the voltage across a capacitor, the current in an electric circuit equals the time rate of change of the charge that passes a given point in the circuit. In example 1, we will discuss about how the indefinite integral works. Based on the example below, we have 2 over square root x, which then later we will forward the number 2 and the x will be power of negative 1 over 2. The power of negative 1 over 2 of the x will then be additional with 1 to get the antiderivative or the result before it being differentiated. The x then will be divided by the same number of the power to get the antiderivative for the number 2. The c in the equations is known to be a constant number, since based on the normal derivative, a number without an unknown will be considered as 0. After we completed all the anti-differentiation, we will then get the antiderivative or the indefinite integral for the number before it being differentiated. In example 2, we will discuss about the usual questions that we will find for indefinite integral or antiderivative. As shown below, using the rules that we have learned from example 1, we can get the answer but with a slight modified rules, especially on the ln x or natural logarithm of x, which if we calculated carefully will become 1 over x. Sometimes our rules need to be modified slightly due to the operation with constant, as shown as the case of the following example. That's all from me for indefinite integral. Thank you.
Hi everyone, today I would like to teach about definite integral. As we all know, definite integral is defined as definition of area under a curve. Area under the curve can be obtained by evaluating the limit of Riemann sum. So as you can see here, the definite integrals can be viewed as limit of Riemann sum. So how do we write this limit of the Riemann sum of the defined integral? Okay, so this is how we write the limit of the Riemann sum. So we have two limits here, which is b and a. So b is known as the upper limit and a is known as the lower limit. So fx is also known as integral. Can you see the fx here? It is known as integral. So this fx is integrated to provide that this limit exists. Okay, so here we are going to see some properties of the definite integral. So let's begin with constant multiple rule. Integral is the multiple of a constant which is c with a function. So c is multiplied with this function fx. We can remove the constant from this function. So can you see the c is removed from this function. So this is the function and the c is removed from the function. So for let's say for example I have this integral 3fx. So how do I remove the constant? So I remove the 3 from this function. So this is one of the example. How do we remove the constant from this function? This integral can be represented in this graph. So here is a function y equals to fx. So if I multiply this function with 2, then it is 2 times higher from this function. Then we have sum rule. So sum rule is actually an integral for the summation of two integrals. So we have fx and gx. So this is the summation of two functions. So here in this graph we have the first function and then we have another function which is known as gx. So the summation of these two functions is known as fx plus gx. Okay, then we have difference rule. So difference between two functions is the difference between two integrals. Okay, now we have definite integral at a point, or can be known as the area with a zero width interval or the area of line segment. So if you see here, the limit is same. It's from a to a. So when you see in this graph, we need to find the area of this line segment. So since the limit is from a to a, so the one dimension of this area is 0. Okay, because there is one dimension, the area is 0. So this is why the value of definite integral is also 0. Then we have the rectangle properties. So rectangle properties is represented by this formula and then this graph. So for example, 2dx from 1 to 4. So this integral can be represented by the line y equals to 2 from 1 to 4. So 1 to 4. So that's why we call this rectangle properties. So rectangle properties, because we can evaluate this integral by using the area of this rectangle, which is 3, because 4 minus 1 is 3, multiply 2 and then we get 6. So this is how the formula we use for rectangle, which is length multiply with width. Okay, so this is how we got the area. Then we have the interchanging the limit. So if let's say we want to change the lower limit a into upper limit a, then we have to put this negative sign here. Okay, then we have addition or subdivision rule. So here we have an integral from a to b. So in the graph also from a to b. Let me write this clear. So this is b and this is c. So if I can split from integral from a to b, I can split them at c, then it means it will be another integral from a to c, and from c to b, and from c to b. So it will be integral from a to c plus integral from c to b. So let me give an example for this. So if I have an integral 1 to 4 and fx dx, and then I can split it at, so you can split them at 2 and it will be 1 to 2 fx dx plus 2 to 4 fx dx. So this is the graph, then the c will be 2 and this will be 1 to 4.
I will explain about the fundamental theorem of calculus with me, Ismail. Fundamental theorem of calculus connects integration and differentiation. Two amazing mathematicians, Leibniz and Newton, exploited this relationship. This enables us to compute integrals using an antiderivative of the integrand rather than taking limit of Riemann sum. The meaning of interderivative here is, let me write I representing the integration and d representing the differentiation. The reverse process from d to I is what we call as antiderivative. Next, let's jump to real-life application of FTC. The fundamental theorem of calculus is an extremely powerful theorem that establishes the relationship between differentiation and integration and give us a way to evaluate definite integrals without using Riemann sums or calculating areas. With this theorem, we are able to calculate the area of the entire curve region by just evaluating the antiderivative at the first and last endpoint of an interval using formula given. Moreover, engineers could also calculate the bending strength of materials or three-dimensional motion of objects. Now, let's go to the definition. If f is continuous on AB, then as below, the definite integrals is the difference of capital F function at B minus the capital F function at A, where f is any antiderivative of f. If the capital F function is the antiderivative for the small f function, thus the derivative of capital F function is the small f function. The equation of fundamental theorem of calculus can be written as this. We have three different parts that we can write the equation of FTC, but the preferred one is the first one, this one. Now let's try example 1. Evaluate the equation using fundamental theorem of calculus. Now let me write the equation for you. 3 negative 2 x squared dx. First step, we have to find the antiderivative for the equation first. So the antiderivative for x squared is x cubed over 3. Rewrite the limit 3 negative 2. The next step is we have to write the definite integrals to the difference of the antiderivative, which is f 3 minus f negative 2. So I continue here we will substitute the limit into the antiderivative, which is like this. So we substitute the limit 3, -2. And then the answer, we will get 35/3. Always remember that the final answer or the definite integrals must be in number, as we know that this answer is also representing the area under the curve. So we have to know the area have to be always in number. Now, example 2. Evaluate this equation using FTC. First, rewrite the equation as what we have done before. At first, we have to find the antiderivative. So, using power rule, the antiderivative is and the limit is 0. After that, the second step is we have to write the definite integrals difference between the antiderivative, which is f4 minus f0. Next, we rewrite the equation and substitute the limit in it. The limit is 0. And then calculate and simplify, we got 16/3. That's all from me. Thank you.